Welcome to this explainer. Let's just dive right in, shall we? Picture this, a machine that perfectly organizes your incredibly messy cupboard, or even better, serves everyone in your house a perfectly customized cup of coffee. That is the ultimate promise of artificial intelligence. Now, we all know AI is built on some pretty complex algorithms, but why exactly do we call it artificial? Well, it's because it's all about engineering human-like intuition into a machine so it can seamlessly replicate exactly what we do.
Which naturally brings up a pretty massive question. What makes a machine truly intelligent? Seriously, what's the secret sauce? We almost always default to sentient robots from our favorite sci-fi movies when we hear the term. But the day-to-day reality of AI isn't always as obvious as a walking, talking android or a fully automated barista hanging out in your kitchen.
In fact, AI is quietly running in the background of almost everything we do. It's right there on your smartphone, it's navigating your car through traffic, and it's absolutely curating your social media feeds. It powers the non-player characters in your video games, detects fraud in your banking apps, and even analyzes complex surveillance footage. It is deeply, deeply woven into our daily lives. But if we strip all those fancy applications away, what exactly does an AI do at its core?
Let's look at Section 1. The Robot Sandbox, how AI actually thinks.
Okay, to really get a grasp on this, let's use a quick mental model. Imagine a robot we've built in a highly controlled sterile lab, and then boom, we suddenly drop it right into an unpredictable outdoor field. The real world is messy, right? The lighting changes when the sun goes behind a cloud, the terrain is super uneven, and the dimensions are completely unmapped. But despite all of this chaos, the AI robot has to perform exactly as expected. This specific ability to react appropriately to a totally new situation is called generalized learning. It is the absolutely vital first step in how a machine actually learns to think.
Now imagine our little robot continues on its journey and suddenly hits a crossroad. One path is smoothly paved, the other is incredibly rocky and treacherous. It has to figure out which way to go based entirely on these immediate circumstances. Assessing that incoming data, paved versus rocky, and making a logical decision to proceed is the absolute perfect display of the robot's reasoning ability.
Further down the path, the robot faces a brand new obstacle, a rushing stream it absolutely cannot cross. But it has a tool. Given a simple wooden plank as an input, the robot figures out how to lay it down and safely cross the water. Taking a given input and actively finding a solution to a roadblock, well, that is problem-solving in action.
So if we put it all together, the crucial formula is this: AI equals adapt plus reason plus provide solutions. Generalized learning lets the machine adapt. Reasoning helps it make smart choices, and problem-solving overcomes the obstacles. These three exact capabilities, working together in harmony, are the defining characteristics of artificial intelligence.
Moving right along to Section 2, reality versus fiction, weak AI versus strong AI.
We really need to draw a hard line here between the tech we actually have running today and the sci-fi we all love to watch. First up, there's weak AI, or narrow AI. This focuses solely on one specific task. For example, AlphaGo is a world-class maestro at the highly complex board game Go, but honestly, it couldn't play a basic game of chess to save its life. That intense hyper-focus makes it weak AI. On the flip side, strong AI is what we see in fiction. Think Ultron from the Avengers. Totally self-aware, capable of developing its own emotions, and highly unpredictable. Now, you might look at smart devices in your home, like Alexa, and think her multitasking kind of blurs that line. But under the hood, Alexa is strictly weak AI. When you ask her to play Despacito, she's literally just picking up keywords and executing a specifically trained program. Try asking a totally untrained complex question, like, say, a highly specific traffic analysis from your exact desk to your driveway, and she fails. She isn't some multitasking, self-aware genius. She's just an incredibly vast collection of narrow, trained triggers.
Which brings us to Section 3, the Russian doll untangling the tech jargon.
So people throw around buzzwords like AI, machine learning, and deep learning almost interchangeably, but I want you to think of them like Russian nesting dolls. Artificial intelligence is the outermost doll, the overarching concept and the ultimate goal of achieving human-like intelligence. Step one layer inside and you have machine learning. This is the specific technique of using algorithms to let a machine learn from data and past experience rather than explicit line-by-line programming. And nestled right there at the center is deep learning. This is a specialized subset that processes data using structures inspired directly by the human brain, allowing it to perceive incredibly complex, subtle patterns way better than standard machine learning ever could.
All right, let's look ahead in Section 4, the visionaries. What's next for AI?
Where is this rapidly maturing technology actually heading? Well, futurist Ray Kurzweil famously predicts that by the year 2045, we will have robots that are just as smart as humans. He calls this the point of singularity, a massive, theoretical threshold where technological growth becomes totally uncontrollable, irreversible, and fundamentally reshapes human civilization. Wild, right?
And the predictions get even more personal. Tech entrepreneur Elon Musk envisions a future where the line between human and machine blurs entirely. He predicts that our minds and bodies will be enhanced by AI implants, effectively turning us into partial cyborgs. It's a pretty mind-bending thought, literally merging our biology directly with advanced algorithms just to keep pace with the very technology we've created.
But hey, before we get completely lost in cyborg futures and the singularity, let's ground ourselves for a second. The human brain itself is still largely a total mystery to us, so it's really no surprise that AI has plenty of uncharted territory left to explore. For right now, AI is fundamentally built to work with us. Its primary purpose today is just to make our tasks easier, safer, and way more efficient. As the tech matures so rapidly, we can really only wait and watch to see exactly what the future holds. Which leaves us with one final thought to really test where we are right now. Which of these AI projects doesn't exist yet? Is it A, an AI robot with full citizenship? B, a robot with a muscular skeletal system? C, an AI that can actually read its owner's emotions? Or D, an AI that develops real emotions over time? Give it some thought. Where exactly is the line drawn today between science fact and science fiction? Think about everything we've covered today, from generalized learning all the way to the strict limits of narrow AI. The answer might just surprise you. Thanks so much for joining me on this explainer. Keep exploring, and as always, keep learning.